In this video, we're going to talk about explicit and recursive rules for sequences, and we're going to learn how to use those rules to predict the next numbers in the sequence. We're also going to talk about a little bit of notation. And so first, let's kind of look at the difference between explicit rules and recursive rules. And so I'm just going to kind of read some definitions and we'll talk about some notation. So an explicit rule can be used to find any term in the given sequence, meaning if I was looking for the 50th term in a sequence, I could use the explicit rule to figure out what that is. And here's some notation that we use. If I say a sub n, that means that's the nth term in that sequence. So for example, if I were to ever say, what's a sub 10? I'm saying, okay, what is the 10th term? Okay, what's the 10th term? And so if that n is what we're doing to refer to where the term is in the sequence, that means that's the position of the term. Like for example, if I said n equals 10, that means we're looking for the 10th term in the sequence. Okay, so kind of be used to that. Now, recursive rules can be used to find the next term in a given sequence. So explicit rules, if I know the first three terms, I can find the 50th. But in a recursive rule, it's good to find the next term in the sequence. So if I'm being completely honest, I think these are used a lot less than explicit rules, but it's still good to know how to read these recursive rules and how to use them. And so a sub n is still the nth term, but then we might use a sub n minus 1 to refer to the previous term. And let's kind of unpack that real quick. So if a sub 10, if a sub 10 is the 10th term, then I would say, I keep writing a 10, a sub n minus 1 would obviously be the term before it, because 10 minus 1 is 9, and that would be referring to the 9th term. So if you see that notation, it means the term before the term that we're talking about, okay? And then n is still the position of the term. Okay, so with this background knowledge, let's learn how to use an explicit rule. Okay, so right here I have three examples. Okay, so we're going to get these three examples, and we're going to use the explicit rule to find the first three terms of the sequence. So, for example, if any given term in this sequence can be described by n plus 1 over n plus 2, then let's find the first term. So that would be a sub 1 would be the first term, and that's going to be 1 plus 1 over 1 plus 2. You see how if I'm finding the first term, I just substitute a 1 in for n. And so that's going to be 2/3, which is our first term. Then let's find our second term, which is going to be n plus 1 over n plus 2, which is going to be, looks like 3/4. And then lastly, let's find our third term, which is 3 plus 1 over 3 plus 2. That would be 4/5. So we have three terms in this sequence. We have 2/3 is the first term, 3/4 is the second term, and 4/5 is the third term. But we could keep going if we wanted to. But basically, this is how I could use the explicit rule to find the first three terms in the sequence, just by basically substituting the term I'm looking for in for n. If I want to find the 10th term, I'd substitute a 10 in for both of those. Okay, let's look at this second one. So let's find the first three terms. So let's find our first term, which is going to be negative 1 to the first times 1. Okay, so I'm putting the 1 in for both n's. That's going to be basically negative 1 times 1, so that's negative 1. A sub 2 is going to be negative 1 squared times 2. Well, negative 1 squared, a negative times a negative is a positive, so that's a positive 1. 1 times 2 is 2. And then lastly, let's find a sub 3, that would be negative 1 to the third times 3. Well, negative 1 to the third is going to be back to being a negative. So it's negative 1 times 3, which would be negative 3. And so we now have our first three terms of the sequence. I could say negative 1, 2, negative 3. You could predict after that it would be positive 4 and then negative 5 if we wanted to. But it just asks for those first three terms. So let's just kind of stop there. And lastly, you're probably getting the gist of it, but this one's a little more complicated. So let's find the first three terms of this sequence. A sub 1 is going to be 2 times 1 plus 1 over 1 squared plus 1. And I guess I can go ahead and do the math for that. 2 plus 1 is 3. 1 plus 1 is 2. Let's find a sub 2. So that's 2 times 2 plus 1 over 2 squared plus 1. Looks like my numerator is going to be 5. My denominator is going to be also 5. And let's find our third term, which is going to be 2 times 3 plus 1 over 3 squared plus 1. 6 plus 1 is 7 in the numerator. 9 plus 1 is 10 in the denominator. So it looks like our first three terms here are 3/2, 1, 7/10. Okay, so I want to reinforce this vocab. These are explicit rules because I could put any number in for n. I could, if I wanted to, I could find the 50th term by putting a 50 in for n, and we could jump all the way to the 50th term. But now I want to look at the recursive rules. In recursive rules, we have to know the term before it, okay? Because referring to each term, it's finding each term by using the term before it, okay? And so this is the first 4 terms of each sequence. I'm going to change that to 3 because ain't nobody got time for that. So let's find the first 3 terms of each sequence. So what these will often do is they'll give you a term in the sequence. So here I give you that the first term is 4. A sub 1 is 4. So if I have that term, I'm looking for the second term and the third term. And so let's kind of read and interpret this explicit rule. It says to find any given term, we're going to do 2 times the previous term plus 1. So in order to find the second term, I'm going to do 2 times, remember this means the previous term, and we've already established that our previous term, if I'm talking about the second term, the previous term is the first term. 2 times 4 plus 1. So it looks like our second term here would be 9. And then let's find our third term here. Our third term is going to be 2 times, once again, the previous term, but if we're talking about the third term, our previous term is the second term. 18 plus 1 would be 19. And you could keep going, but note, to find each term, if we're using this notation, we have to use the term before it to get there. Okay? Let's do one more example. Now we're starting with a first term of 2. Okay, so I'm going to take 2 comma blank comma blank. Let's find the first 3 terms again. And so to find the second term, we can take the previous term, which would be a 2, plus n, which if we're looking for the second term, our n is 2, and then subtracting 1. So 2 plus 2 minus 1, it looks like that our second term is going to be a 3. And then let's find our third term. To find our third term, we are going to look for the term before it, which would be a 3, because we're looking for this term. The term before it is a 3, plus n. We're talking about the third term, n is 3, and then we're subtracting 1. So it looks like 6 minus 1 would be 5. And we could keep going with that. So once again, for a recursive rule, we're always going to be referencing that term before it, and you're going to see this n minus 1 notation to reference that.